15 years of experience and a background in environmental science, Paul brings a wealth of knowledge to his industry. He is a licensed British Columbia builder and active member of Vancouver's Home Builders Association and Passive House movement, implementing healthier building standards that benefit the community. Paul approaches every project with care and works closely with clients to make sure their home fits their lifestyle and needs. So with that, Paul, please take it away.
Hello, everyone, and thanks for being here. Thanks for taking time out of your day to come hear a little bit about us and our projects that we got going on. And yeah, can everyone see my screen okay? Nice. Perfect. I want to say thanks to House Accelerator for having me on, and yeah, everyone else that's shown up today to listen in. So a little bit about us. We're a small and relatively new company based in Vancouver, and we feel very fortunate to have the opportunity to work with such great clients who have believed in us along our way, as well as designers, architects, engineers, and tradespeople. Our primary focus is to build houses that are healthy places for our clients to live, as well as building methods that maintain the health of the environment that our houses live within. Because of these focuses, Passive House has been a natural fit for us, and we believe strongly in the wide-ranging benefits that come from its challenging energy targets. Throughout my Passive House journey, I've had the good fortune to work with, as well as learn from some amazing people in the industry here in Vancouver that have acted like mentors to me in the early stages of my Passive House journey. So I want to mention a few. Pierre-Andre Santon from Mizu Passive House Consulting has been someone I've always been able to look to for advice or information when I've been in a jam. He's always been keen to help and gracious with his experience and knowledge. Lucio Pigiano from TLP Architecture has done a great job to bring Passive House knowledge to Vancouver. I think he built the first certified Passive House in the city, and I've had the pleasure to work with him on many projects throughout the last 6 years or so. Also, Arthur Lowe. I worked as a project manager for Arthur at Insightful Healthy Homes. Arthur's been a pioneer in the healthy home building industry in Vancouver. He's always pushed the envelope, no pun intended there, on creating homes that perform to a higher standard years and years before there were any requirements to do so. And finally, the last one, I want to acknowledge Adam Corneal quickly, who founded the Unbuilders in Heritage Lumber. He's been a champion in the deconstruction industry here in Vancouver, and has done a lot to keep our old growth wood that has built Vancouver out of the landfill and putting it back into circulation. And then a little bit about me. I come from a carpentry background, studied at the University of Waterloo. I studied environmental science. My first experience with Passive House came about 6 years ago in 2017, when I built two Passive Houses simultaneously across the street from one another. So it was two at once. They started about a month apart from each other. So it was a bit of an initiation by fire. There were a lot of confusing conversations because they were just north and just south of each other. So there was a lot of, did you say the north elevation of the south house or the south elevation of the north house? And me kind of running back and forth between the two to make sure we hit our energy targets on both, but we managed to do so. So jumping into a bit of my thoughts on Passive House and where it's going, the future of Passive House. So in my opinion, the success of Passive House, the Passive House method, has come from its challenging yet straightforward energy targets. It's provided an easy to follow framework that guarantees a building will operate in a highly efficient manner while offering many other benefits for the occupants of the building. It really is a fantastic certification process that has upped our level of energy performance throughout the construction industry and shown us that we should be expecting more from our buildings. So how you reach the Passive House energy targets, however, is non-prescriptive, which leaves room for extremely varied structural envelope strategies. This freedom of choice is a good thing, but it necessitates that we as builders, designers, tradespeople, and homeowners, we must be thoughtful in our approach to ensure that operating energy consumption savings provided by passive house are not nullified by the embodied carbon within assemblies that are inevitably much thicker, heavier, and contain more stuff. I kind of like to think about the total weight of a house or the mass of a house, and comparing old buildings to new buildings. And maybe there's been studies done on this over the years, but yeah, but thinking about the weight of a house built in the early 1900s compared to a modern passive house, a modern passive house, must be 3 times, 4 times heavier than that traditionally built house. So in that extra mass, yes, we are seeing huge benefits in dramatically reducing operating energy consumption, but we have to take care about not doing this at any cost and forgetting that our primary goal here is to build healthy buildings for ourselves and our environment. So this presentation will case study 2 of our projects to show how some of the methods we've employed reduces overall embodied carbon within an assembly strategy. So the majority of this presentation will look at our completed Kitsilano EnerPHit Plus project, and we will touch lightly on a new build project that we've just broken ground on earlier this week. So our Kitsilano EnerPHit Plus project, we turned a single family home into a duplex, and the home was actually had been in the family of the clients that I worked for about 60 years, and the house was gifted from the grandmother of the family down to the granddaughter and the grandson. So in doing so, they thought they both wanted to live there, so they thought they'd turn it into a duplex, and they also had the ambitions to turn it into a passive house duplex. So because of the positioning of the house and the zone it was in, it is in an RT7 zone in Vancouver, which has a bit of heritage status. So if they would have torn the house down completely to build new, they would have lost quite a bit of square footage. So it opened up a really good opportunity to go the EnerPHit route, which was very cool and exciting for us. It's our first one. So the house itself was very typical for its time. It was slab on grade, 2x4 framing. The main living area was on the upper floor, with the mechanical room and flex space in the lower floor. It had had a few cosmetic renovations over the years, but all in all, it was in pretty rough shape. There were a couple holes in the roof that had been patched over with like 6mm poly, and there was asbestos around every corner. But it was a very loved and lived in house, and had a lot of memories and sentimental value tied to it. So it was a cool idea for the clients to maintain as much as they could of the house, as well as for us to jump in, to an EnerPHit project. So I'll just kind of go through, to focus in on a few key aspects of the project. Our foundation strategy, it was simple enough: insulated footings with ICF foundation walls. The tricky bit was to get the house out of the way before we could do the work. So with the help of an amazing excavation team and a house lifting company, we decided to place our supporting stilts outside of the footprint of the foundation and use large enough steel beams to clear span carry the load without intermediate support. So this kind of opened up the full foundation footprint that we could work unimpeded in, which is somewhat atypical for this kind of work. The cribs are usually placed inside the foundation, and then you build the foundation around them and then remove them after. But as you can see in the photos here, we did luck out in taking this approach, because as we started to dig out the foundation, we found dozens of car or small car-sized rocks in the soil below the house, which then we had to hydraulically split and remove them with excavators. So it was, yeah, a pretty crazy experience to be under the house and pulling these car-sized rocks out with the house above us. But I mean, when it rained, we had a big umbrella over us the whole time, so that was kind of nice. Yeah, here are a couple of photos. On the left there is the foundation finished. We're starting the first floor framing there. The second is the middle photo there is a photo from inside the foundation with our under slab insulation going in. And our slab, in this case, it was one kind of strategy of reducing concrete, which is a highly has a lot of embodied carbon in it. So we actually used a plywood slab, a 2-layer plywood slab, opposed to concrete. So we had to ensure the substrate below the EPS was super flat, so that the foam went down super flat, so that our plywood could lay down without kind of bouncing all over. But yeah, we thought that was a really cool way to, because it was a non-structural slab, to remove concrete out of the picture there and use plywood instead. And then the third photo there is, I believe, on pour day of the foundation. So you can see the house kind of floating above. Yeah, so our structure upgrades and layout changes. We, turning a single family home into a duplex that would seem to be home for 2 young families was a challenge, but we managed to squeeze 3 bedrooms and 2 bathrooms into both units while maintaining a living space that felt spacious and open. Vancouver has a definite lack of real estate options that fill the gap between condo living and then single family homes. So it's always good fun to be able to add density to neighborhoods that typically don't, and kind of fill that gap. Yeah, so to accommodate the new layout, the structural changes were pretty big. No part of the house remained untouched. But as we deconstructed section by section, we were diligent about keeping any framing material that we thought was good enough to reinstall back into the house. So you can see in this first photo, new wood kind of living harmoniously there with old wood as we'd pull it out, and then where we could, we'd add it back in, to pay tribute to as much as we could to the old structure. And here are a couple more photos there of that technique. Yeah, so the EnerPHit, our envelope strategy was, very, very typical, kind of very similar to what we do in a new build. So here it was 2x6 framing. Usually we're 2x8 in Vancouver with a new build, but we were 2x6 with 4 inches of exterior mineral wool. We used a self-adhered membrane, which acted as our primary air barrier strategy as well. The roof assembly consisted of 4 inches of polyiso, and then 4 inches of mineral wool, which gave us enough art value that we didn't have to insulate on the interior, like the rafter cavities, which is kind of nice. So yeah, a bit of the calculations here. Our heat load demands were target was 15 kilowatts per hour. We managed to hit 0.3 air changes per hour. And then we put a PV system on the roof, which produced about 7.2 kilowatts per hour for both the front and the back. So combined, it was about 14.4. And yeah, here are another couple photos of the new the house kind of taking its final form, or its new shape, and putting on its new passive house envelope layers. And I really, this is my favorite part of any passive house project, because you can start to sense that the first blower door is just around the corner. So you can feel the importance of the diligent detailing of membranes and tapes, because that test is coming soon. And also Adhero Blue is a beautiful thing, thanks to Sean. And then in the middle there, you can see our guy Reed ready to cap off the top. Our final blower door score was 0.3, which we were happy with, and very much in line with our other passive house projects. And I think it was our blower door score that kind of sealed the deal of receiving the EnerPHit Plus designation. I think it was a bit lower than we had anticipated, which was good. And then the finished roof was a standing seam metal, which made it easy installation of our PV system, which put us into that net neutral energy consumption window. And then here's the duplex in its final form. This is the backside. And at this point, the homeowners had happily moved in. And we were able to maintain an aesthetic that fits the neighborhood, and just kind of give it an updated look that felt fresh and modern. So this back unit faces south. So they've really taken advantage of the indoor-outdoor feel, and we installed a 14-foot wide folding door system that floods their space with natural light. So overheating during construction was a concern. So we do have a large canopy above the back lower opening, so above that folding door. And then we installed a heat pump as well in the back unit for cooling in the summer. And here are a couple more photos of the back units, the finished interior, and the client really wanted a fireplace, really wanted gas in the house, which we reluctantly told them we weren't going to do that. So we installed I don't know if you can see it there, but an Optimist fireplace, one of those misting fireplaces, which we were actually really thrilled about, and the client too, for an electric fireplace, how good it looked. And here are a couple photos of the front unit. So yeah, the two siblings had very different styles, but maintained a similar layout and feel throughout the homes. So throughout this build and my previous builds, I've become a bit of a sibling specialist throughout my passive house journey. Dealing with this one, I had a brother and sister. So the sister was in the back, the brother was in the front. And then on the houses I mentioned before, where I was building two at once, it was actually two sisters and their families building directly across the street from one another. So I was juggling those siblings as well. So if I ever need a second career path, I could definitely become a family counselor of some sort. So that's a side benefit. So yeah, I think that the EnerPHit way of going is a very interesting and cool way of tackling the passive house requirements and achieving an energy efficient home, while also focusing on reducing embodied carbon, because inherently with a project like this, you are using less framing material. We estimated about 30% less. I mean, most of the house was reconstructed. So they're, starting out, we thought maybe it would be more than this, but there was a lot of reconstruction needed. Just the shape of the house was, it was pretty old and in rough shape. So, but yeah, we still were able to save that much. Also nice to create density in a neighborhood that is majority is single family homes. And then instead of, we reduce concrete in the basement slab, we installed a 2-layer plywood slab instead, which I thought was a really great way of reducing concrete. And then, yeah, back to just using as much of the deconstructed framing material as possible. We were just really diligent throughout the process of setting everything aside and then reinstalling as much as we could back as we frame back up. And then, yeah, the PV system on the roof got us to the point that we were essentially net zero with the build. So that's it for the EnerPHit portion. And I want to touch briefly on a project that we have coming up. We actually just broke ground on Monday. So that's exciting. So this project won't be a passive house, but a lot of passive house principles will be used in the construction of it. But we are putting a lot of focus on sustainability / embodied carbon in the materials we choose. So our wall assemblies in this house will be 2x6 framing with reclaimed wood. So we're trying to source as much reclaimed wood as possible for the wall and the roof assembly. And then the cavity insulation will be a sheep's wool insulation and wood fiber board insulation on the exterior. And then the exterior cladding will also be it'll be made out of reclaimed framing lumber as well. It'll be an open cladding system. And it's a technique that I'm actually borrowing from Arthur Lowe from Insightful Healthy Homes. They've recently done a cladding system like this as well on one of their Living Building Challenge houses. And it looks incredible. So really the focus on this is that sort of embodied carbon. So we think tackling a wall assembly like that and a roof assembly like that will be a really kind of cool way of doing that. And then, yeah, inside the house as well, we'll use as much reclaimed wood for the finishings as well, flooring, interior wall finishings, and as much as we can there. And then, yeah, another interesting thing we're doing on this one is the foundation walls were, well, first of all, we're doing very minimal excavation on the project. It will be set on bedrock. So we've designed the house to kind of float above the bedrock. And you can see there in the red, that red triangle down there, we've got a bit of a crawl space basement. So that red space runs about 50 feet, and that's the only excavation on the entire project, removing a bit of bedrock. And then we're actually going to use that excavated rock inside the concrete foundation to create a rubble wall foundation. So it still will be concrete, but we'll have slightly thicker walls, and we'll use a lot of that rock as filler, which will then hopefully somewhat expose it on the exterior side. So you see a bit of that rock coming through. So we think that's kind of a cool way of using a material from the site and also reducing concrete usage. So, yeah. And that's pretty much it for my presentation. So thanks so much again for everyone that's here and listened in. And I think we'll open up for questions.
Thank you so much, Paul. This is really cool to see, projects that are taking embodied carbon and embodied energy and incorporating it in the design and in retrofit, nonetheless, from the very beginning. So that's really exciting. Everybody is very excited about a lot of these different methods, and they want to ask you about things. First, I'm going to turn it over to Sean, though, because I know he's seen at least one of these projects, maybe both, in person, and has a couple of things to note about them.
Yeah, if those that again need more of this or in the Vancouver area, either let me or Paul know, because he's done some amazing work, and we can actually kind of do and we didn't do it in the Passive was open days, but we typically do a bike tour, and Paul's two projects on East 41st, where he talked about the sibling rivalry, actually created two beautiful passive homes that were under Paul's supervision, and we'd definitely like to showcase those. So hopefully maybe in the next few weeks we might be able to put together again a summer passive house bike tour on the what I call the unofficial passive house Street of Dreams here in Vancouver, where we can showcase Paul's great work. The particular project that he spoke about today, I mean, I'm super excited on, because one of the things that I learned, we talk about an air barrier detail. I thought that you might be able to get away with just doing membranes. And doing a retrofit myself, I definitely realized that making the upgrade to vapor open peel and stick, makes your air barrier details so much easier. And he got to 0.3, I think, on his first floor door with such ease. And I was like, okay, I'm going to follow Paul for any future my retrofits, with going to a peel and stick product to wrap your house around. And I know Lucio, the architect that he's worked with, has done that on many projects. And I always wondered, oh, is that an extra cost that we should maybe avoid and stick to membranes? And definitely on a retrofit, I would almost swear by it, seeing the difficulties that I've had with some specialists that didn't quite get the air barrier details, and seeing Paul's hard work and his score, I'm like, okay, you sold me on that particular detail. But Paul, I'd love to ask you a first question more about that plywood slab. I mean, there's been a few questions in the chat here, and I actually didn't realize you went to that level of detail. And I mean, I probably would have spent more time bugging you on site to showcase it. So now I get the pleasure of asking you now is, can you just describe that detail of the plywood slab a bit more in detail, of just kind of how you manage the vapor barrier and the air barrier, and how you did that connection? And because I'm assuming again that the foam, like the ICF, like I remember seeing that the walls and the footings are concrete, but just can you just describe that detail of the slab a bit more, if you don't mind?
Yeah, totally. So our slab area was kind of broken up into 4 quadrants. So we were able to kind of work quadrant by quadrant. And so first of all, we used crushed stone underneath. So just at footing level of crushed stone. But that was kind of the most labor intensive part, is to, like, typically you can just pour concrete over top of uneven, put your poly down and pour concrete over top of uneven gravel. But we had to spend the time to level out and screed that gravel to make it perfectly level, because we knew that anything at that layer would kind of transcribe through the insulation and then result in an uneven floor. And we decided to do this after the first floor system was on too. So it was just a crawl space foundation. So we only had about 4 or 5 feet down there to be working with gravel, and we had too much, so we're taking some out, and then we took too much out, so we had to throw some back in, and we're down there leveling the gravel. So it was that, and then it was 4 inches of EPS insulation. With the poly, then we used a Perminator, I think 15 mil poly, that just sat in each 4 quadrants, which we then taped up to the ICF walls and to the concrete footing as well, on the interior footings. And then plywood over that. So we did 2 layers so that we could cross. We did, one this direction and then the next this direction to cross the seams, so that it worked as kind of one diaphragm plywood sort of slabs. It was all connected, all one piece. And then after that, it was kind of open to the clients to floor it however they wanted. So they just got some inexpensive click-in vinyl flooring that we put down there, and yeah, it's great.
Awesome. Great stuff. Again, great project. And again, thanks for your leadership and your dedication to keep persevering and doing the incredible stuff. It's great to see these projects locally. So thank you.
Thanks, Sean.
Yeah, thanks for the presentation, Paul. And we do have a lot of questions coming in, which hopefully, Sharzad, yours at least got answered just now about the subslab membrane. But before we jump back into the question queue and Kim has put on who is up next, we're just going to break quickly for a message from sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
We are going to start off with Roberto. I believe your first question regarding the foundations was answered, but you had a second question about the reclaimed wood, if you want to come on and ask that one.
Sure. Paul, actually just going back to the foundation, or not the foundation, sorry, the slab on grade. Were those two layers of plywood nailed together or fastened or glued together in any way? Or are they loose laid?
Yeah, they are. So they're glued and screwed together.
Okay, gotcha.
Yeah.
The question I had for reclaimed wood is that what we found is there's a lot of ambition to use reclaimed wood for all kinds of like interior finishes, which is great.
Mm-hmm.
Easy to do if you can find it. And then there's the portion of the building community that actually wants to use reclaimed wood for like studs,
Mm-hmm.
and, structural components. And there's some structural engineers that'll be like, we're not doing that because it's not new. And I think there's a trust with new studs, 2x4, 2x6, whatever it is, 2x10, 2x8, that they're willing to, allow their load to bear on those new studs. But for reclaimed wood, are you finding structural engineers that are okay with reclaimed wood?
Yeah, so I mean, it really depends on your engineer, and that's the biggest thing. Some really have bought into it and believe that the load capacity is more, because it is older wood from potentially bigger trees with tighter grain. It was also, we used to frame with our class, better quality material, like class J, where now we're kind of like number 2 or better. So it's classified better back then. So it really depends on your engineer's perspective. I've been lucky enough to find one that really believes in it. So that's great. So yeah, that has been a big hurdle, and I think it's a hurdle that a lot of people encounter. But as long as your builder is using diligence and obviously using material that doesn't have huge checks in it, or isn't have holes from previous services coming through and whatever. I mean, you have to be choosy, but it definitely can be done.
Who would inspect the wood? Would you inspect the wood, or would the structural engineer inspect the wood?
The structural engineer would. Yeah. So I mean, they're not going to come and inspect each piece. They're going to use rely on your common sense to do the sensible thing, and then come and assess. Like at framing inspection, they'll come and assess at that point. And if there's anything that they want pulled out or redone or whatever, they'll let you know. The other thing to note on this as well is any amount of reclaimed wood is a benefit. So if you can have that conversation with your engineer about what parts they are, and use new material where they really want it, and use reclaimed where it matters less. Even in partition walls or in non-load bearing areas of the house. I think you can get away with it, almost without asking. But again, it's So it's not an all or nothing. I think there's a lot of middle area that can be, we can make use of.
Thanks, Paul. Great work out there in the field.
Thanks so much.
Caleb Crawford also mentioned, mostly my engineers hate new wood if it isn't engineered lumber. They tend to over design since contemporary wood is not great. So it's kind of the other end of the argument. Okay, I think next we have Timothy. You had a key question here on fireplaces. Do you want to unmute? Is Timothy still here? Okay, I will ask the question because I think it's a good one. He says, beautiful project. Does anyone have a spec on the electric fireplace, and is that hood over the fireplace? And in general, how are we doing fireplaces with an EnerPHit project?
Yeah, I mean, great question. I really like a fireplace in a house as well, so it is something that we do have to consider in building more airtight and energy efficient homes. And my client kind of felt the same on this project. They were really pushing for one, but we did a bunch of research and found, I think it's called the Optimist something, but it's essentially a misting fireplace that's plumbed in and then releases a mist along with a bit of a light show, which sounds a bit, not the greatest, but it actually looks really real, and it does give kind of that, that nice fire ambiance. So we were really happy with it. They were really happy with it. I was a bit concerned about it at first, but it seemed to work out. So.
Awesome. I think up next we have Mohammed Reza, and I think you had 2 questions. Feel free to ask one or both if we have time. And if not, we can ask it for you. Give you another second. So the first question, Paul, was whether you compared, oh, no, okay, I thought we had him joining. Whether you compare the retrofitting costs as a passive house with traditional retrofit costs.
Yeah, we've done a bit of internal research into that after the project finished. And I would say it sits very similarly to the differences between a traditional built new house and a traditionally built passive house. So we found that it was roughly 10 to 15% more to do it this way, opposed to if we didn't. Although in Vancouver, and I don't know what other municipalities are doing, but in Vancouver anyways, we do have step, well, throughout BC here in Canada, we do have step code coming in. So these policies are being pushed at a provincial level. So traditionally built homes are no longer what we think a traditionally built home is. The step code is requiring that we, as a whole across the province, start lifting that bottom level closer and closer. So that price difference is really becoming smaller and smaller as that happens, which is great.
And Mohammed Ezra, if you can.
Hi, sorry.
There you are.
Can you hear me?
Yep.
Yes.
Sorry, I lost some parts of webinar because of my lack of my internet. So I wanted to ask you, there is a belief among people that they think that passive houses are really costly and they are gonna, I don't know, charge us a lot of money. And even in my country or in Europe, because I'm from Iran, and how we can actually do something, some strategies, some, I don't know, advertisement to change this belief. I think that because in this field, I've read a lot of papers that they said that, I don't know, passive houses are cost near 3% or 4% in Europe. And now people don't know anything about these kind of things. How you think that we can change it? with I don't know, with a strategy, with an, I don't know. This is my question.
Yeah, I mean, I think a big part of the conversation around that is appealing to, I mean, the energy consumption aspect of Passive House is huge, and combating climate change with that strategy is obviously a big priority. But I do find with homeowners, especially, appealing to them with the idea that it is a smaller, or it is a bigger investment, but you're getting a better product. You're getting a house that is, you know, a lot more thermally comfortable. It has better air quality. It has, you know, it's quieter. There is just a lot of benefits to the homeowner directly in their everyday life. That, you know, that small percentage when they're building something, they're going to directly see, as well as, you know, the long-term energy costs of operating a house are dramatically reduced. So the client, I've recently spoke to them. It was just as we were coming out of winter, and I talked to the one client about their energy bill, their heating costs throughout the winter, and they said they were getting energy bills for about $6. And I think in Vancouver we're billed bi-monthly, every 2 months or something. So it was like $3 a month for them to heat their house. And that's offset with their PV system. But at the same time, I mean, that investment up front pays dividends in the long run. So.
Thanks. Yeah, this is one of those ongoing conversations that we all want to keep having in the realm of Passive House, and you know, how do we justify it? And it's it might be cost, it might be a lot of the soft benefits and attributes as well. So yeah, thanks for providing kind of those specifics for these projects. Next up, we have Jean. Jean, do you want to unmute yourself and ask your question?
What did I ask?
You were asking about the wall framing. Does that ring a bell?
Yeah, you started off saying it was a 2x4 frame structure, but I thought later on you said you built it out to 2x6. What, or did I mishear?
No, that was right. So originally it was a 2x4 structure. So on this house, the upper floor was really the walls on the upper floor were the only ones that were retained. The lower floor walls, once we lifted the house, we actually just cut them off because the foundation below was in terrible shape and at you know, a bunch of different levels. So all the walls were inconsistent and in rough shape. So we essentially cut the bottom walls off of the house as it was lifted up. And then so the new walls on the lower floor were new framing at 2x6. And then on the upper floor, they were the original framing, and we just furred out to 2x6 to make that cavity a 2x6 cavity.
Thank you.
Yeah.
Okay, we have Joe Gatemi, if you want to unmute yourself.
Yeah, hello. I saw you had briefly mentioned using sheep's wool as an insulation material. I hadn't heard of that before. I was intrigued by that and just wanted to ask about any detail on that.
Yeah, so it's a 100% sheep wool product that you can get from a few sources. I've used it on one renovation project so far. You do have to get someone to stamp on it, so either an architect or an envelope specialist or something to sign off on it, because most districts, municipalities are not going to be, it's not, you know, in their list of an acceptable installation. So it does have to be signed off on, but it is, the product we've used is called Havelock wool. and it comes in batt form and I think a blown in insulation as well. And again, I mean, it's really one of those instances where I think people just feel more comfortable when there's more mechanization behind a product, because the more mechanization there is, the more paperwork there is for that product, which then, for liability reasons and all sorts of things is a comfort zone for people, where I do think we have to be less scared of these natural materials, because they are sustainable, sometimes the more sustainable approach. And yeah, I mean, it is one of those instances that it is putting that liability onto an architect or an envelope specialist as well, but yeah, I mean, it totally can be done.
Thank you very much. If I may briefly ask just one, hopefully small question, how is the, R value on that insulation, and how is it for? Is there any moisture retention concerns or anything like that?
So, I mean, it's very similar to a mineral wool product as far as R value, which is great. And then sheep's wool is actually hydrophobic as well, so it actually pushes moisture out, just like mineral wool does as well. And it's also antimicrobial, so it doesn't allow any molds or bacteria to grow, which is great. It's also really nice to install. It's not itchy. We typically in-house at our company, we don't install our own insulation, but when we're doing that, we're happy to do so. It makes the house smell like a barn for a while, which is kind of nice too.
Excellent, thank you.
Robert also asked in the chat, what about combustibility? And Sean was saying it has a borate additive, much like many other insulation materials, so it is not combustible. But I guess I'm wondering, based on that, just because I haven't looked into it, do we know anything about what does adding borate do to any of the sustainability aspects or embodied carbon, or just health of a material, or anything that we have to consider there? Maybe this is a you question, Paul. Maybe it's for Sean or anybody who knows.
Yeah, I mean, I'd probably pass that to Sean. I wasn't fully aware of the borate additive. So is that something that, Sean, that Havelock?
Yeah, they have to add it for North America for codes. And I mean, when you look at the overall embodied carbon, I know when we look at the lovely website that we all looked at, that had insulation. I mean, sheep's wool was definitely in the middle of the pack between, in the organics. And I know even when you add the bit of the borate, it does move it up, but it's still way below all the embodied carbons, that we're looking at. So it's minimal. It's only like 3% of the overall kind of like ingredients when you look at the insulation. So, but I know they just need to add it for some of the code issues that comes up.
Thanks. Yeah, I guess it's helpful to understand just relative to other things, how much does it matter if we're adding in an additive or something like that. So thank you. Next up, we have Holly. Do you want to unmute and ask your question?
Sure. It was great to hear about the embodied carbon strategies you used. Did you quantify those at all with any type of life cycle analysis?
So not necessarily. We definitely want to more, but as of now, we haven't spent a ton of time. Really, it's more at this point, without doing the research into it, more of an ethos and more of, especially with the reclaimed wood, we just feel very strongly that this is an approach that makes a lot of sense. Instead of a lot of it either going to landfill or being chipped up for paper products or something. It's an amazing way to kind of pay tribute to the materials that have built our city here in Vancouver, and also have a circular product that can be put back in. But no, we haven't done the strong research on it to show any data.
Okay, and I'm not sure whether that also answers Paul Heron's question. I believe you had a question specific to the beam tool. And if that does answer your question, there's Paul.
Hi, Paul. I really appreciate what you're doing there. It's near and dear to me as far from a reuse of existing building materials. And I've done the concreteless slab as well. It's a great method. But one of the questions I have when I'm evaluating today is, have you used the Builders for Climate Action beam tool to help you evaluate and make choices between the new products that you're using in these retrofits to reduce your embodied carbon?
Yeah, we've used it a little bit, but it's not something we're using on a daily basis. No. Yeah.
Okay, thank you.
Yeah.
Awesome. We're going to break for a second. We do have Salvatore, who's, I think, our last up.
Hey, all. I have a few questions, but one related to the slab. I may have missed this, but the vapor control layer, was this placed below your insulation, or was it something you were going to subsequently do that precedes that photo?
So yeah, so it was placed on top of, I believe it was placed on the warm side of the EPS. So between plywood and EPS. Yeah.
Okay. And the stove or the fireplace discussion, and this is always a very interesting topic when talking to clients who are traditionally like to have a fireplace. And I try to talk them into wood burning stoves and try to find fireplaces or actually wood burning stoves that are closed combustion. And we tend to show overheating when we model it. And I was wondering if you or the rest of the group may have some input on what they might recommend in terms of trying to source a stove. I've looked into stoves that have water-fed jackets, a very European approach to circulating water around the stove and dissipating and reclaiming about 60 to 70% of that heat and doing something else with it. In some cases, maybe heating a driveway, melting snow, where you don't need it in the house. The EPA, I guess, has outlawed this in the United States in terms of, because those stoves just don't meet those EPA standards, and they're not considered stoves anymore. They're considered appliances. So that's the challenge that we've come against. I was wondering if anybody had or came across some solutions that could deal with conditions where a client wants something like a wood burning stove, but we don't want to deal with the overheating that comes off of it. Any thoughts?
I mean, it's a great question. And I think it's one that a lot of people are thinking about in our new build project that we're kind of embarking on now. It has spec'd a wood burning stove, and it will be it will be one of those things that we'll have to figure out experientially how it works. And it won't be the primary source of heating at all. It'll be something that's used more for, because this project is based in a more cabin community where it's allowed. So it will be more of a an ambiance thing, more so than a direct heating that is used once a week or something. So, but beyond that, it's an ongoing challenge.
Yeah, that was the first thing I noticed about the location of the fireplace, which was right along that, almost fully open wall of window. And it sounds like Sean was saying that's the approach that another project took. I guess one of Michael Ingby's projects was just to open the windows in that scenario, which is counterintuitive. But I think that takes us through the queue of questions, but Zoe and I always have a burning question for all of our speakers, and Zoe's going to ask it this week.
Yes, just to know, if you have any other burning questions, feel free to put them in the chat. We can go a little bit over today, but because we're coming up on the end of the hour right now, we'll ask, what do you see as the future of Passive House and high performance building, kind of from your experience here? And I know you had a really nice intro where you talked a little bit about this, but is there anything that you want to talk a little bit more about or introduce here?
I mean, not so much. I think the same kind of key ideas of using more natural materials into, like, I just think that with the wide array of strategies that people come to with Passive House, we just have to be thoughtful again in how we build them. And although two houses may perform the same, the materials within are definitely not the same. So just tackling that in a more meaningful way. And I think municipalities have a big part to play in this as well, as enabling more natural materials within our buildings. And so I hope that's the future.
You're here to policy, which takes us back to Beverly Craig's first message. If you joined early enough, she dropped an awesome link about Massachusetts Embodied Carbon Challenge. So yes, to policy that moves us forward in this direction. Paul, thanks so much for sharing your projects. Thank you all for your questions and discussions back and forth in the chat. It was very lively today, and I loved everybody answering each other's questions. There's the link again, Kim. Thanks for dropping that for Masses Policy Challenge. Zoe, any final thoughts?
No, I love this discussion just because, a lot of people's answers to our question on the future is that we need to be looking at embodied carbon and other environmental effects. And, Paul's providing an example of doing exactly that. So we're in the future in that sense. And maybe even more future is quantifying all the comparisons. And of course, we have folks asking about LCA, and so this is all new and exciting. And yeah, thank you so much, Paul, for sharing what you're doing as the future here. So thank you, and thank you all for joining.
Yeah, thanks again, everyone.